How, how's everyone doing today?
Yeah.
There was a lot to get set up, but I think everything is working. There's 2 hardware demos, which in hindsight was a terrible, terrible idea, but I think it's going to work, so we'll give it a try. Yes, this is exchanging data wirelessly with a Bluetooth Low Energy and a ZigBee. Has anyone actually programmed with a Bluetooth Low Energy or a ZigBee device before? Okay, sweet. So part of the talk is going to be about the protocol and what sort of things you need to know in order to interact with these devices. And then part of the talk is going to be the actual Python code to interact with both ZigBee radios and Bluetooth radios. And so first up, just setting up a little bit of motivation. This is a little washed out. I don't know if people can see okay. But this is in my basement. I bought a house about 2 years ago and started doing a little bit of woodworking, making some shop furniture, that sort of thing. And I very quickly accumulated a lot of wood scrap. And I noticed that if I just left the wood scrap, it would sort of crack and it wouldn't be as usable because it was slowly getting destroyed. And so I really wanted to keep an eye on the temperature and humidity in my basement. So that's precisely what this little guy is doing. It's got a little temperature and humidity sensor on it. And then I have a dehumidifier and sort of the wood pile in the background. But I was having trouble figuring out how to get this data where I needed it. I had a Raspberry Pi up in my living room, and I had a Arduino in my basement, but I didn't really want to like drill a hole through my floor. And I also wanted to learn a little bit about these wireless technologies. And so that's what sort of set me down this path of trying to figure out how to operate Bluetooth radios and ZigBee radios. This is sort of the topology I was just describing. I only have one temperature humidity sensor in my basement. I would also really love to have one in my garage along with this NFC shield, so I could use like an NFC card to open and close my garage door. I haven't quite got that far in my home project. But I do a lot of wood finishing in the garage. It's nice to have a certain temperature and humidity balance there as well. So just trying to gather data from these remote sensors and then bring it into a centralized location to the Raspberry Pi, but not having to run wires throughout every room in my house. So the first system that I tried to do this with was Bluetooth. I'd used a ton of Bluetooth devices before. Everyone probably has like some sort of Bluetooth speaker or like a Bluetooth headset or that sort of thing. And I was like, how hard could it be to actually program? Yes, I see someone laughing who has tried this before. It turns out it's horrendously complicated, but I'm gonna do my best in about 25 minutes to describe to you what the process looks like. For those of you who aren't as familiar, I wanted to just sort of quickly do a compare and contrast between programming Wi-Fi and programming Bluetooth and what those 2 different systems look like. Pretty much everyone is familiar with Wi-Fi, I think. More recently, there are Wi-Fi protocols that run on 5 gigahertz, 802.11n, but the majority of it, A, B, G, is all 2.4 gigahertz. Bluetooth is the same. I don't know the actual FCC designation, but when they were chopping up the spectrum, they decided to leave this chunk, 2.4 gigahertz, for lots of consumer devices. And so that's why you see a lot of Bluetooth, Wi-Fi. Microwaves emit a lot of 2.4 gigahertz. If you've ever wondered why your Wi-Fi connection drops whenever you're making popcorn. Other similarities. So in Wi-Fi, or more precisely in the Internet Protocol, every hardware device, your laptop, your smartphone if it's connected to a Wi-Fi network, has this 12 hex character MAC address that uniquely and individually identifies that device. Bluetooth is the exact same thing. When these Bluetooth devices are manufactured, they're given a unique 12 hex character device address. And so the Bluetooth radio that's in my laptop, I have here an Arduino just hooked up to Adafruit's Bluetooth sensor. When it comes out of the factory, it has this unique address that you're going to need to interact with it. Other similarities, comparison, contrast. The range is not great. So for Wi-Fi, if you have sort of like a medium-sized house, you can have one base station, it'll be just fine. Bluetooth is not. It's meant as a personal area network. And so, of course, it depends on the antenna of both the transmitting and receiving device. But in my experimentation, it covers about half of my house on one floor, and it does not communicate very well between floors, which we'll discuss a little bit more about in a bit. Another thing to keep an eye on is power usage. I have this crazy dream for the past 7 years of having like an automated chicken coop someday. Yeah. And so I wanted to have some sort of system that I could extend to either be powered by solar panels or otherwise have a battery system that didn't have to be replaced very often. So this is the great thing about Bluetooth, particularly Bluetooth Low Energy, is that the power consumption is quite a bit less. These devices are just plugged into the wall. I have plenty of outlets in my basement, but that could be a consideration depending on the project that you're working on. And then probably the biggest difference is the topology. So when you're using a Wi-Fi connection, maybe you're looking at doing something like in your house, like file sharing or printing to a wireless printer, but most often you're connecting to the internet, and who knows where those servers are? They could be in another country, they could be on the other side of the United States. And so the way that the system is constructed, it's sort of this network of networks, and you have these nested topologies. In your home network, you probably have IP addresses like 10.0.something.something or 192.168.something.something, and then it uses a NAT or a network address translation in order to connect to other larger networks that connect to other larger networks. Bluetooth doesn't really have any of that. It is really meant just for devices that are sort of around you. And so in that way, things are a little bit simplified. The other difference is that in Wi-Fi, all devices are equal, more or less. That's absolutely not the case in Bluetooth. You have to have a concept of sort of a central device and a peripheral device. It gets a little bit confusing because for something like a cell phone, depending on the context, it actually switches what role it is. So if I'm connecting my cell phone to my laptop to share a picture, there my smartphone is a peripheral. And if I'm connecting a Bluetooth speaker to my smartphone, there the smartphone is a central device. So these roles aren't cast in stone, but when you're figuring out how to pair them up, you need to sort of keep in mind which one is going to act as the central device and which one's going to be the peripheral. And they're all one-to-one connections as well. So if you have a device connect to another device, no one else can connect to that peripheral. It's sort of taken up by that central connection. So something to think about when you're trying to make a topology of your devices. Sweet. Okay, so that was sort of the high-level overview. Now to sort of dive into some of the technical details. So the most recent version of Wi-Fi, at least that's prevalent in consumer devices, is 802.11n. I think there's an 802.11ac. I don't know if it's actually left draft status or not, but if you buy a laptop, it will most likely support 802.11n. For Bluetooth, there's Bluetooth 4, and unfortunately, that's not enough to understand how you're going to use the device. There's at least 3 different modes in Bluetooth 4. We're going to be focusing here on Bluetooth Low Energy, but there's the other 2 parts are Bluetooth High Speed, which is for longer-lived connections or transmitting a lot of data. So if you're transferring files or if you're playing music, you're probably going to be using Bluetooth High Speed instead. And then there's also a 3rd mode, Bluetooth Classic, for backwards incompatibility. I am fairly new to Bluetooth, so I don't really know much about those other ones. This talk is going to focus on Bluetooth Low Energy specifically. And one of the reasons why it's so low energy is that the messages are tiny. So again, in the Internet Protocol, there's a maximum transmission unit of 1,500 bytes. And I just learned this past week due to an interesting project at work that in some networks like Amazon Web Services, they actually bump this up internally to be 9,000 bytes. But if you're transmitting data across the internet, the standard says it can't be larger than 1,500 bytes. Bluetooth Low Energy, in part, is so low energy because the radio is never on for very long, because the maximum message size is 20 bytes. So you have to be really careful about what data that you're going to transmit, because it's kind of hard to cram much information into that length. If Bill Gates were here and it was the 1980s, he might say 20 bytes is enough for anyone. I don't believe that to be the case, though. You need to sort of really think about the data you're transmitting if you're going to use Bluetooth Low Energy. The Bluetooth stack that I'm using for this talk is BlueZ and is specific to Linux. I believe there's Bluetooth stacks available for Windows and Mac as well, but the technology I'm using for the Bluetooth portion of the talk is specific to Linux. And so on a Linux machine, just like you'd use iwconfig or ifconfig to configure your wireless radio, we're going to use HCI-config to interact with our Bluetooth radio. The connection process between the two is also quite different. For a Wi-Fi device, you are probably using DHCP, where when you connect to the network, it gives you an IP address, and it remembers the mapping between the IP address and the MAC address, and it shares it with other people on the network so they can share information. So you have one central server or one central service that's probably built into your wireless base station that's sort of handling that assignment. In Bluetooth, nothing is handling that assignment. You have to manually go through the pairing process, which is sort of complicated in its own right. And then in terms of service discovery, so usually when you're on a Wi-Fi network, you know what you're trying to access. Maybe you're trying to get to YouTube. Maybe you're trying to get to Pinterest, Snapchat, whatever the website of the month is. And so if you're doing that, you're using a service called DNS that's sort of translating a network name to a IP address. But for Bluetooth devices, because it's just meant for things that are around you, there isn't that same sort of coordination. Instead, there's something called the GAT, which is a generic attribute transfer. I'm not actually sure what the last T stands for, but it's a way of querying different devices that you see on the network for what sort of information that it can provide. And then, again, for an internet protocol, you have all these different protocols, DNS to figure out IP addresses, HTTP, HTTPS to download web pages, maybe you're using IMAP to check your email, or XMPP or something like it to chat with people. Bluetooth is this incredible fractal of different services that are offered. And they're also hierarchical, which makes it sort of additionally tricky to get the information you need. At the top level are devices. And that's basically things like a smartphone, things like a glucose monitor or heart monitor. And if you look on the Bluetooth specification, or if you look at the Android documentation, there's a whole list of different Bluetooth devices. And it's really weird. It's sort of like Google's vision for the future. There's smart jackets, which I think were actually announced at Google I/O this year. Oh, it's getting really dark in here all of a sudden. OK. But there's also things like smart watches. And so at the highest level, a Bluetooth device has to sort of fit these different categories. The Bluetooth specification doesn't really want you to come up with your own device, which will cause a problem, as we'll see in a second. Below that are profiles. Probably the most popular profile is A2DP. That's the one for streaming audio between two devices. So if you have like a Bluetooth speaker or a Bluetooth headset, somewhere there it's using A2DP. But if you want to exchange other data, like if you want to exchange heart rate information, or if you want to exchange files, those are different profiles as well. And then each profile is made up of a different set of services. And a service might be something like, can receive data, can transmit data. And then in order to interact with that service, you need to know the specific characteristics that enable or allow you to transmit information. And so this is hopefully starting to convey the nightmare of organization that is Bluetooth. So if you're trying to connect to a web service, all you need to know is probably the name of that web service. All this other stuff's sort of figured out for you. But in Bluetooth, there's all these different pieces of information that you need. So let's start out trying to collect those pieces of information. So just a brief recap. We want to know the hardware address of the device we're trying to connect to, so we can skip the pairing process. We want to know what kind of device it is. We want to know what profile it offers, and that profile will be made up a series of service UUIDs that we'll have to know the address of to actually interact with it. And then we need to know the specific hexadecimal characteristics in order to interact with that service. So let's go on this mission here. The first thing that we're going to do is we're going to gather device information. So there's a couple of different ways to do this. The shortest one that I could fit on a slide is to use a Bluetooth cuddle. And it's just a Linux command line tool that supports a bunch of different commands. We can turn scan on for our laptop, and it will start trying to discover devices around it.
So it started an interactive session?
Yeah, so if we'll be in the REPL in the next slide, and you'll see the three less than or greater than signs. Here, the pound sign just means that we're on a root shell. Yeah, and so it discovers a device address, and it's hooked up to my Arduino, and I was able to give it a name of Pi Ohio to make sure that I'm not discovering different people's smartphones in the room or whatever. And then we need to figure out these characteristics of the device, and so we can query that hardware address, and we can get back this characteristic UUID. So we're about halfway there. So now let's jump into some Python code. This is using a library called BTLE, and it queries the BlueZ the BlueZ Bluetooth stack for Linux. There are probably like 5 or 6 different libraries that people use to interact with Bluetooth. This one happened to support the particular things that I wanted to do and demonstrate. And I think it's pretty good, but if you wanted to experiment and sort of survey the field, or if people have recommendations after the talk, please let the group know. And so the highest level of organization in this library is a peripheral. And so I'm going to instantiate one. You have to give it the device address. And there's 2 types of device addressing in Bluetooth 4 to be additionally confusing. There's normal, I think, and random. The only clue that I sort of found online is that devices that are sort of created in a more ad hoc way and play a little bit fast and loose with the Bluetooth spec tend to use this random address type. I would just recommend trying each, though, and seeing which works. And so once we've connected to that peripheral, we can take the UUID that we got on the previous slide and use that to actually get the different characteristics of that service UUID, and then just have a little loop to print out the handle of them, and also convert the properties to strings so we know what the heck they're referring to. And so this UUID spits back 2. There's E, hexadecimal E, which is notify, and there's hexadecimal B, which is write, no response. And so this was a little confusing. It took me a little while to wrap my head around. But just like the keynote talking about async, the Bluetooth radio communication is also asynchronous. And so if you want to send data to it, that's fine. You can write and not expect any response back. But if you're expecting a response back from the device, you have to enable a notification handler. And it turns out there's one last piece of information that we need. And so just we also need to know what hex string that notify characteristic is expecting in order to turn notifications on. So there's a couple of different, you can enable notifications, you can disable notifications, you can do other things. This, again, I found in the Android Bluetooth documentation and source code, which is a tremendous resource for making sense of the literally thousands and thousands of pages that make up the Bluetooth spec. So here, our reconnaissance is complete. We have the device address. Unfortunately, this board that I bought from Adafruit does not expose a standard Bluetooth device profile. It's a UART for asynchronous receiving and transmitting of serial data, but it's unofficial. So there's no device profile, which makes things a little bit more complicated. But we can sort of bypass that because we know the service UUID. We found the 2 characteristics, and we know what we need to write to that characteristic to make it happen. So finally, we are ready to write our simple Python Bluetooth Low Energy program. Just like before, we're using the BTLE library. Just like before, we connect to the peripheral. What we're doing here, though, is that we are setting a callback. So the wondrous world of async has not yet permeated Bluetooth libraries. But the way that works in this library is you create a delegate class, you define a handle notification function, it gets a bunch of crap, and then the actual data. And so here we're just going to print the data out. We set the delegate on the peripheral. We write to the notification characteristic, the enable notifications hexadecimal string, and then we write to the write no notify characteristic, this little string. I defined a very simple protocol between my laptop and the Arduino. Basically, the first character is a ASCII length indication, so just 0 through 9, and then how many bytes the string itself is. And if you send it hello, it'll respond back world. If you send it anything else, it'll just respond unknown. So fingers crossed. Let's pop open a shell here. Oops. I wonder if it's possible to make this a little bigger. Nope, maybe not. So my program here is, just, oh, sorry, with the text highlighting, that's pretty much impossible to read. It's basically the same as on the slide. It's sending this message, hello. Let me make sure that my Bluetooth device is plugged in. Yeah, the little green light came on. That's a good sign. Cool. So we sent a hello to it, and it responded world. If I go into my program, and I wonder if it's possible for me to quickly turn off the text highlighting. It looks like maybe not. But if I take the hello message, and if I change it to, I don't know, let's say Pi, Ohio, and I send that message instead, and assuming nobody else is connected to my Bluetooth device. Oh no, I think I must have set the wrong message. Yeah. Okay, well, let me try a shorter message. And then my C Arduino program is not very good at exception handling, so I'm just gonna reset the. That's right. Yeah. Yeah. Just check your return stats on every line. Everything will be fine. Trust me.
Don't forget one time.
Yeah.
So you've got
Okay.
a
Cool.
program running in your Arduino, using a Python program running on your laptop to chit chat with it.
Yeah. So if I had two laptops and they both had Bluetooth radios, I could sort of have Python running on both sides. It was a little bit easier for me to pack these extra Arduinos instead. Yeah. And after the talk, if people are curious, I'm more than happy to share with you the C code. It's very straightforward, and there's documentation with all these different Bluetooth boards as to how to send and receive data with them.
So it's the C code that
Is responding back.
fussy, that it needs to be told how many characters to stir again.
That's exactly right. Yep. That's exactly right. Cool. So that's Bluetooth. But unfortunately, when I set this up and was trying to transmit temperature and humidity data, half my messages were literally being dropped on the floor because the floor of my living room or the ceiling of my basement is sort of like made of this thick material. And I got like every other message. And I was like, okay, well, it half works, literally, but I really want it to work all the time. And I have these grand plans of maybe having a Arduino that's controlling the plug on the humidifier, because it doesn't have a really good temperature sensor on it. It's like 0 to 9, or a really good humidity sensor. And so it could actually actuate it. But if I'm only getting every other data packet back, I'm not quite sure that's reliable enough. So I decided to start researching these ZigBee radios. ZigBee radios are really cool. They are much less structured, which is both great if you're sort of like not quite anarchistic, but let's say like have a libertarian worldview. But it's also sort of like enough rope to hang yourself. So again, just doing a quick overview, comparing these two different systems. ZigBee also operates on the 2.4 gigahertz spectrum. Thank you, FCC. The devices, though, don't have any sort of individual addressing. They were meant to be part of mesh networks. And the more advanced ZigBee radios actually have some mesh networking protocol built into them. Those are the Series 2 radios. This one is a XBee Series 1, so it's a little confusing. ZigBee is the protocol. XBee is the manufacturer of this specific board. For the S1, when it transmits information, it will be received by any other radio that's in range, but it doesn't have a mesh networking protocol where it repeats messages and redelivers them. You transmit it, if anyone's in range, they receive it, and that's pretty much it. So because of that, you don't need an individual address for the different devices. You can have a 4-hex character network ID, though, which gives you sort of a lot of space to play in. And so if you're worried that all of your neighbors are going to create their own ZigBee wireless network, maybe they're all watching this Pi Ohio talk, I don't know. There's plenty of space for you to sort of play in to make sure that you're not interfering with each other. The range is also quite a bit more substantial. This radio has on it a physical antenna, which is great for range. And also, it's transmitting at 1 milliwatt, which might not sound like a lot, but for a radio signal, it's actually quite substantial. Even if you had like an acre property, that might be stretching it a bit, but it can transmit quite far, and is a little less susceptible to floors and walls and stuff like that. Also, so of course, the power usage depends on how frequently you're transmitting, but it doesn't use nearly as much power as a laptop. It actually, the power usage might be comparable to the ESP8266. That's a dedicated board that has sort of a Wi-Fi module on it. But generally speaking, a device with a battery plugged in would last for days instead of hours like a laptop. And then again, with a Wi-Fi network, you have this nested topology where your ISP talks to other ISPs, talks to different service providers. But here, it's just literally point to point. You have these devices, it transmits out a message. If any other devices are within range, they receive that message, and then they can interpret it, respond to it, that sort of thing. And then diving in again to some of the more technical details, the ZigBee specification is 802.15.4. Thank you, IEEE. And the specific one that I'm using here is the S1 radio. I think that the S2 radios are actually a proprietary protocol built on top of it, but I like open standards. They're nice. In case you need to dive into the specification, you can and sort of see what's going on. The MTU is a glorious 100 bytes, which by itself wouldn't seem like a lot, but coming from Bluetooth, I was like, I can pack all sorts of information in here. And then the interface that it exposes is a little bit unusual. So it has the series of pins down here that exposes a serial interface. And this is a totally legitimate FTEI chip that lets me communicate with it over USB. But it behaves like a modem, actually. Yeah, so I'm dating myself a little bit by talking about modems, but I will undate myself by saying that, yeah, I never had a separate modem that was like on top of my computer. I always had the modems that were like PCI cards. But apparently, when you had the modems that sat on top of your computer, you would plug it in with a serial connector, and then it would send a series of these AT commands to communicate with it, to configure it, to transmit data, that sort of thing. And then sort of now we're getting into the part where it's like enough rope to hang yourself. So there's no connection protocol, there's no protocol at all, and there's no services. It's all up to you. The radio will turn on, it will transmit messages, it will receive messages, but that is about it. You sort of need to figure out all the other pieces there. And so just like before we dive in, there's a little bit of reconnaissance and configuration we need to perform. So again, here with the hash, I'm on a Linux terminal, but every operating system has some way to communicate with modems, hyperterminal, I don't know. I'm sure your platform has a way to communicate with modems, or yeah, with the serial devices. And so I'm just using Minicom on Linux, connecting to my USB connection. And then I recommend turning on a local echo so you can see what you're typing. And then also carriage return so it doesn't end up on one line. And so I had to read it up a little bit about the AT protocol, but I guess you send 3 plus signs to sort of wake up the receiving device and have it be aware that commands are incoming. It does have some sort of timeout, so you can't just do plus 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 and then go make a sandwich and come back. It will pay attention for a limited amount of time to commands after you do that. So here, just some basic AT commands. We want to set the network ID so that we're not interfering with anyone who's using the default factory settings. We want to check the baud rate. We're going to need that later to communicate with the device. It comes back 3, but looking at the documentation, that's 9,600 bits per second. And then for myself, I wanted to play around a little bit with rolling my own encryption, which is a terrible idea for a production system, but for a mesh network that's in your house, I think is probably okay. So this device actually has a really great system built in. It has the ability to write an encryption key to it, but it can't be read back out by the software. And I don't know how special the hardware is, if it has a specific secure element that makes it additionally difficult. But it's nice, because even if you gain physical access to this radio, you can't read the encryption key out of it. You could overwrite it, but you couldn't get my encryption key at home. So ATEE turns on encryption, ATKY sets the encryption key, and then very importantly, before you disconnect, make sure you do AT-write. That'll write out all of the settings to the flash memory in case the device loses power. So that'll use those settings again when it starts up. So this is sort of in contrast to the nightmare of Bluetooth Low Energy. This makes it much, much easier to sort of interact with this device. All you basically need is to make sure it's configured correctly, and then you can plug it in. And so in rolling your own protocol, there's a few things in particular that you want to be aware of. So there's a couple of different ways to set up your protocol. You can have fixed message length. You could have the message length specified in the message, or you could have some sort of like message type, where like message type 1 is 10 bytes, message type 2 is 20 bytes, whatever. So I just chose to have a message length. Because we have 100 bytes to play with, this is no longer a ASCII 5. It's a unsigned 8-bit integer, so that I can use the whole length of the message if I want to. The other thing to look out for, which is sort of like a ridiculous network quirk that you might not be aware of unless you write a lot of networking C code, is that there's this thing that is called network byte order. So apparently different platforms, x86 or Atmel or ARM for Raspberry Pi, have different ways that they store multi-byte integers. And so I think that if you're on an x86 device, or if you're communicating over the network, you're supposed to use big endian, which means that the most significant byte comes first, and then the least significant byte happens after that. But platforms like ARM use little endian, where the least significant byte comes first, and the most significant bytes happens later. And so this isn't important if you are on a single platform, but if you're trying to transmit things between ARM chips on Raspberry Pis and Atmel chips with Arduinos, you want to make sure that everything is in network byte order when being transmitted, and is being decoded from network byte order so that you are getting the same values back. In our protocol, every chunk of the message is 1 byte, so this doesn't matter so much. But I wanted to make you aware of this in case it's something that you end up using in the future. So here's our Python ZigBee program. It uses all Python built-ins, so it's completely portable. You could run this on any platform. It's pretty simple. We're going to use serial, struct, and time. First, we set up our serial connection using the information that we got when we were interacting with the minicom. And then we use struct to make these byte-packed messages. So just like various types of string formatting or date timestamp formatting, it has its own specification that's in the Python documentation. Exclamation point just means that you should use network byte order. Again, it's not strictly necessary here, but it's a good thing to be in the practice of. There's going to be one 8-bit integer unsigned, and then there's going to be a string that's 5 units long. And then there's our integer, there's our string, and you just write the message. This is a million times better than Bluetooth. It's just so simple to read and write back and forth. We sleep for a second, and then we read 1 byte to figure out how long the response is. We unpack that using the same format as before, and then it returns a tuple. So you just want to access the tuple so that you actually have the integer available. And then you can read that length. We're using string formatting to put in the length into the struct formatting arguments, and then we just print it out. And so let's see if lightning can strike twice here. I need to be in the ZigBee directory. I need to unplug my Bluetooth device that hopefully no one was having fun with while I was talking. I need to plug in my Arduino plus ZigBee radio, and I need to plug the other ZigBee radio into my laptop. And then, unless the USB port numbering changed, I should be able to run this program that we just showed. Oh no, that doesn't look good. Unpack requires a string argument of length 1. I am not really sure what that means. That's quite possible. Yeah, so the nice thing about the ZigBee radios too is that they have 2 indicator lights. So the green flashing means that it's on, and then it should show up the red when it's transmitting or receiving. So if you keep an eye on that, let's see.
Yeah, it's red now.
Okay, sweet. I guess it just took a second to sort of start up. And then again, just for demonstration purposes, if I go into my program, again, apologies for the syntax highlighting, and I change my message to be Pi Ohio, and this time, I don't know, like a...
You gotta change it to 6 from 5?
Well, so this time I'm a little bit of a smarter programmer. I'm taking the length from the message instead of having it hard-coded.
That's crazy.
I know, right? So yeah, this is what you get when going from embedded systems to actual system engineering. But hopefully that will respond back. Yeah, unknown. Cool. Yeah. Cool. And so that's basically it. This was the screenshot I took before coming here. And just a plug, I guess, for an open source project that I have, Tiny Feedback. This was born out of wanting to collect data from a bunch of servers in production. So it's a way of doing a HTTP post of a key value JSON dictionary. And then it can very easily create graphs of that over time. So the Raspberry Pi collects the data from the Arduino. It does a HTTP post to the server. And then I can sort of graph my temperature and humidity over time and make sure that things aren't getting too crazy. And that's really it. So thank you, guys. I think I have some